welcome to lesson 8. We're going to clarify polynomials. So here are the two things that we're going to look for that show you have mastered the skill, that you can identify the polynomial. So you can tell if it's a monomial, mono meaning one, if it's a binomial. So if I see binomial, I have two terms. A trinomial has three terms. And anything more than that, we just use a polynomial, poly meaning many. So binomial has two, trinomial three. Poly is anything more than three. We use that. Instead of saying quadrinomial or pentanomial, we don't say that. We just say polynomial. And then if we can identify the degree, and we do that by adding the exponents of a variable. So for example, if I have something like this, x to the third y, I would add these together. There's actually a little one here for the y. So this would be a fourth degree. But if I have something like 5 to the third, there's no variable over here, so it is still 0. Why, you may ask? Well, 5 times 5 times 5 is 125, which be 125 with an exponent of just nothing. There's no exponent now, so there's nothing there. It's a 0. All right, so these are things you're going to look for, and I want to make sure we really understand the difference in being able to recognize monomials. So again, monomials have one, so these are all one term versus not monomials, which have many. They're polynomials in disguise, so we don't want to confuse them. All right, so let's start by looking at our monomials. So if you see a constant or just a variable by itself, easy peasy. However, it's possible you can see a coefficient and variables is still monomial. They're still one term. They're all together. They're grouped together. Or if you see a variable with an exponent, it's still part of the group. It still counts as a monomial. These are all one term. Now, for the ones on the right, cases where they are not true, I'm going to start with the middle one. It's the easiest one. Actually, I want to do this in red. 5y minus x. You can clearly see there are two terms there. There's a 5y and subtracting x. So I'm doing two things. Same thing with this one here with that fractional bar. We have two terms. We have 3 as a term being divided by x to the 5th power, which is another term. So what about this one over here? I thought this first one, I'm going to put it in blue because it looks so different. Like, why is this not a monomial, but this one is? So what's the difference between this one and this one? Look and see if you can tell what it is. Okay, it's that negative sign. That -3 makes a difference. Why? Because we know how to express negative exponents. When I have a -3, I have now 1 over 1/10 x to the 3rd power. So this is I'm using my negative exponent rule to change that. And now you can clearly see two terms. So this is sneaky. It is a sneaky binomial. It was just hiding there. Okay, so when you see a negative exponent, we know that it is not a monomial. So with that, let's look at the list we have here. The first one, yes, very, very easy. It is just a variable with a whole number exponent. I'm just going to put exponent. Now, the second one, square root of x, honestly, depends on what. Is x a perfect square? So if it is a perfect square, like let's say it's just if x was equal to 4, then yes, because I can simplify that to do and it would be a monomial. But what if I had, trying to think for a minute, 8, square root 8? Well, then no, because we know we can split this up into this, and it will simplify to 2 square root 2. And now I have two terms here, so that would not be monomial. All right, let's look at the second one, 5 to the 2nd power. Yes, it is. It would simplify to one term. It would just be 25, which is just a number. How about the second one, 10 divided by x to the third? No. There are two terms. We have x and we have x. Oops, sorry, not x. We have 10 and x to the third power. So we have two terms there. And the last one is pretty easy. It's a no. Again, we have two terms, 5x and 10. All right, so hit pause and jot this into your notes. All right, let's look at the degrees. I want you to read that first paragraph to yourself, and then we're going to look at how to find the actual degrees and how it's classified. All right, so in this first one, they're classifying this polynomial 6x to the third minus 5y to the second x to the second as a fourth degree binomial. So I can clearly see why it's a binomial. I could see that there are two terms. But how are you getting the fourth degree? I don't see fourth in the exponents. Well, if you read your notes, it's because you're adding the two. So in this first one over here, this is just a third degree. But here, because you would add those together, it would be a fourth degree. And you're going to use the higher. You don't say you have a third term binomial, fourth term binomial. You would just use the bigger term, which is the 4, and that's why it's a fourth degree binomial. In the second part, you have a second degree trinomial. So the trinomial makes a lot of sense because you can see the three terms here. 1, 2, 3 terms. And again, you're looking at the degrees on top. Now, this is again where you can get super tricky because at first I saw this 3 and I was like, well, isn't that a third degree? No, it is not, because there is no variable. Okay, so that one gets tricky. It's just 5 to the third power, which would be 125. So we have to look at the ones with variables, and here you have a 2, which is a second degree, and here you don't have any, which would make it a first degree. And again, we use the biggest one, so second degree. Okay, so that's what we're going to do. Let's try it out in this next problem. Let's classify this. All right, so looking at the first one, I have 3 terms. So this is definitely a trinomial. And let's look at the degrees. So here on the first one, remember that x doesn't have anything, so it has an invisible 1. So that would be a third degree. Here in the second one, I have x to the second and y to the second, so that would be a fourth degree. And in this last one, it would be a second degree. Again, because it's x to the first and y to the first. So this is a third degree trinomial. Okay, so that's what the first one would be. So thinking about my notes for a second, did I identify the polynomial? Yes, I identified this as trinomial. I recognize there are 3 terms. And did I identify the degree? Yes, because I added the exponents of the variables and I chose the largest as degree. So I've met both my points. I've demonstrated I know how to do this go. Let's do the second one. Here I have 2 terms. So this is a binomial. And let's look at the degrees. The first one, a to the first and b to the second. So this is a third degree. And the second one is also a third degree. So this is a third degree binomial. All right, hit pause and jot this down into your notes. And start practicing these sessions. Again, remember your big points you're going to demonstrate. You know how to identify the polynomial with the correct name. If it has more than 3 terms, just call it a polynomial. And identifying the number of degrees. And look out for terms that have an exponent but do not have a variable. That's it for today's lesson. I will see you in the next one. Be well.